Ever wondered how mathematicians group things together? The answer is sets. Now, you might be thinking, what on earth are sets? Well, in the simplest terms, a set is a collection of well-defined objects or elements. By well-defined, we mean that there's no ambiguity. For instance, if I say the set of all students in class 10, it's clear who belongs to that set and who doesn't. Now, these elements in a set don't have to be of the same kind. They could be numbers, letters, ideas, people, or anything else that can be clearly defined. The beauty of sets is that they allow us to group these elements together in a way that makes sense and can be easily understood. And remember, in a set, each element is unique. There's no room for duplicates here. So, in essence, a set is a simple, unorganized collection of unique elements. Now that we know what sets are, let's dive into the different types of sets. First up, we have disjoint sets. These are sets with nothing in common. Picture two circles with absolutely no overlap. For example, the set of all dogs and the set of all cats are disjoint because there's no animal that is both a dog and a cat. Next, we have infinite sets. These are sets with an endless number of elements. Think about the set of all natural numbers. There's no end to it, right? That's an infinite set. Then we have something called a power set. It's a bit of a mind bender. The power set of a set is the set of all possible subsets of that set. For instance, if we have a set with elements A and B, the power set would be the set of all subsets, which includes the empty set, the set containing A, the set containing B, and the set containing both A and B. Speaking of empty sets, let's talk about them. An empty set, also known as a null or void set, is a set with no elements at all. It's like a basket with nothing in it. Lastly, for this scene, we have the singleton set. This is a set with just one element. Picture a set containing only your favorite color. If your favorite color is blue, then the singleton set would be blue. Of course, these are not the only types of sets. There's also equal sets which have exactly the same elements and complement of a set which includes everything not in the set. Then we have subsets, which are sets contained within other sets. And finally, we have the concept of intersection of sets, where we look at what elements different sets have in common, but we'll dive into those in upcoming scenes. These are just a few types of sets. There are many more to explore. Wouldn't it be fun to visualize these sets? Let's see how. Enter the world of Venn diagrams, an ingenious method of illustrating sets and their relationships. Picture a rectangle. This represents the universal set, a home for all possible elements. Now imagine circles within this rectangle, each one symbolizing a different set. Take two sets, set A and set B. Each circle contains elements unique to that set. But what if there's an overlap? Well, that's where the magic happens. The overlapping section or intersection holds elements that belong to both set A and set B. Think of it as a party where both tea lovers and coffee aficionados are present. The tea circle has all the tea enthusiasts. The coffee circle houses the coffee lovers. But that overlapping zone? That's where you'll find those who relish both beverages. With Venn diagrams, we can easily visualize and understand the relationships between different sets. Now, let's learn how to play around with these sets. In the world of sets, there are several ways you can manipulate and interact with them. One of the first concepts you'll encounter is that of a subset. A subset is simply a set that contains some or all elements of another set. For instance, if we have a set A with elements apple, banana, cherry, set B with elements apple, banana is a subset of A because every element in B is also in A. Even a set with no elements, often called an empty set, is considered a subset of any set. Next, we have equal sets. Two sets are considered equal if they have exactly the same elements, irrespective of the order in which they appear. For example, if set C has elements, dog, cat, bird, and set D has elements, cat, bird, dog, even though the order of elements is different, C and D are equal sets because they contain the same elements. Lastly, we come to the complement of a set. This concept is a bit like looking at what's missing from a set compared to a universal set. The complement of a set A in relation to a universal set U is a set of all elements in U that are not in A. Let's say our universal set U contains all the alphabets and our set A contains vowels. The complement of A in relation to U would then be the set of all consonants, because these are the elements present in U but not in A. These concepts, while seemingly simple, form the basis of many mathematical operations and proofs. They allow us to compare, contrast, and understand the relationships between different sets, providing us with a powerful tool in our mathematical toolkit. And that's how we manipulate sets. Quite interesting, isn't it? To recap what we've learned today, we've journeyed through the fascinating world of sets. We started with an introduction to sets, laying the foundation for our understanding of this crucial mathematical concept. We defined what a set is and explored its various depictions. Next, we delved into the various types of sets, from disjoint sets to infinite sets, power sets, empty sets, and singleton sets. Each type of set we discovered has its unique characteristics and applications. We then moved on to the visual representation of sets. We used Venn diagrams to visually depict the intersection of sets, subsets, and the complement of sets. This visual tool we found makes understanding sets much more intuitive and engaging. Finally, we explored the art of manipulating sets. We learned how to create equal sets, identify subsets, and understand the interplay between different sets. Remember, sets are everywhere. Once you understand them, you'll start seeing them in your daily life. So keep practicing and keep exploring.